Welcome to the structure analysis 1. This is the continued lecture of displacement of statically determinate structure in which we are complete all the cantilever beam type example with double integration method and Macaulay's method too. Now we are going to study simply supported beam and example solved by the same in which we are complete a one method in which simply supported beam is loaded with a point load in a middle. Second, simply supported beam with UDL on entire span. RA is equal to RB is equal to W into L divided by 2. As I say, total load divided by 2. જ્યારે mirror action થતી હોય take origin at A, consider section X at a distance X from A. Let us first, we have a beam AB simply supported over one side and roller supported at second. Total length of beam is L. Loading is W kilonewton per meter as a uniformly distributed load. Take a section at somewhere in beam from X distance from the A point. Now find the MX. MX is equal to moment at X is equal to W into L by 2 into distance X minus load W L square by 2. But in case we have L is equal to X, that's why W L square by 2. Finally, we have MX. Now integrate it. EI d square y d square y upon dx square is equal to minus mx, which is our equation, in which put the value and integrate at once. Therefore, EI into dy by dx is equal to minus W L x square divided by 4 plus W x cube divided by 6 plus C1. Take limit 0 to L by 2. Or take x is equal to L by 2. Dy by dx is equal to 0. Simplifying all this, we have a final answer as a C1 is equal to WL cube divided by 24. And put this C1 value in this equation. We have EI dy by dx is equal to minus WL x square divided by 4 plus WL x cube divided by 6 plus WL cube divided by 24, which is the equation of slope. Integrating once again, EI y barabar is equal to minus WL x cube divided by 12 plus WX4 divided by 24 plus WL cube divided by 24 into x plus C2. Similarly, put the values of x and y is equal to 0. C2 is equal to 0. Put the value of C2 in this. We have an equation of a deflection. EIY is equal to minus WLX cube divided by 12 plus WLX raised to 4 divided by 24 plus WL cube x divided by 24. The maximum slope is at support. Substitute x is equal to 0 in equation 1. The term 0, 0 and the last term is a positive WL cube by 24. That's why the angle at theta A is equal to WL cube by 24 EI. Okay. Similarly, maximum deflection is at a mid span. So substitute x is equal to L by 2 in equation 2. There we have the double the value of L and above. L square 24, L raised to 5, 24 into 2, L raised to 4, 24 into 2. That we have the values, and to simplify it, we have the final answer as a YC as a deflection is equal to 5 divided by 384 WL raised to 4 upon EI. Second method, in this case, a simply supported beam with a UDL up to half of the span. When only half span is loaded with UDL, deflection at mid-span will be equal to the half of the deflection the in case of the beam with UDL on entire span. Okay, so the final answer is equal to YC is equal to 5 by 382 84 into 2 WL raised to 4 upon EI is equal to 5 by 768 WL raised to 4 into EI. So we only consider the equation and the theory too. It is a very useful in examination, mostly MCQ exams. Now, simply supported beam with eccentric point load. Let a load WB placed at A from A and B from B. RA is equal to W into B divided by L. RB is equal to WA divided by L. As we know from mechanics of solid, A as a origin. Consider section X at a distance X from A in AC. Mx is equal to WB by L into X. From X less than A, EI into d square y upon dx square is equal to minus mx. But we know from the here a beam A B eccentrically loaded W L distance A distance B takes X at somewhere here. So let's find mx. Mx is equal to WB by L into X. Okay. So integrate it. EI dy by dx is equal to minus w bx square upon 2l plus c1. Put the value x is equal to a and dy by dx is equal to theta c. So c1 is equal to ei theta c plus wba square divided by 2l. We have this equation of flow. Sorry, ei dy by dx is equal to minus w bx square divided by 2l plus wba square divided by 2l plus ei into theta c. Integrating once again and put the at a point x is equal to y0 x is equal to 0, y is equal to 0, c2 is equal to 0, ei into y minus wb x cube divided by 6l plus wba square divided by 2l x plus ei into theta c into x. There is equation 2. And for x greater than a, consider a section x in a portion CB. That here we have here to here W B into L into X minus W X minus A. Okay, and do the similar process, and we have the respective equations. Okay, now we are going to start of double integration method with a simply supported beam. Example 1. Find slope and deflection at point C for a simply supported beam loaded as same shown in figure using first principle. Take EI is equal to 6 into 10 raised to 4 kilonewton into meter square. A beam A to B simply supported beam distributed UDL is a 20 kilonewton per meter. ACCD 222 total length is equal to 60 kilonewton. 60 kilonewton. RA is equal to RB is equal to 20 into 6 divided by 2. Total load divided by 2 is equal to 60 each side. Now MX is equal to 60 into X. This 60 into X, and for UDL this the similar portion covered in A to X 20 into X square divided by 2, okay, is equal to 60x minus 10x square, which is our mx. Put the value of mx in this equation and integrate it. We have 10x cube by 3 minus 16x square by 2 plus c1 dy by dx is equal to 0, x is equal to 3, 0 is equal to 10, and we have the value of c1 to solve it. Now ei dy by dx is equal to 10 by 3 x cube minus 13x square plus 180, which is the equation of slope. Integrate it against EIY is equal to 10x raised to 4 by 12 minus 13x cube divided by 3 plus 180x plus C2 at A. X is equal to 0 and Y is equal to 0. So C2 is equal to also 0. Now EI into Y is equal to, put the value of C2. The rest of the thing are similar. The thing is changes, C2 is equal to neglected because it is 0. That is the equation of deflection. For slope at C, substitute x is equal to 2. मतलब આપણે જે જગ્યા ઉપર ડિફ્લેક્શન ફાઇન્ડ કરવાનું તેની વેલ્યુ મૂકી દેવાની. જેમ કે મારે 2 મીટરે ફાઇન્ડ કરવું છે તો 2, 3 મીટરે કરવું હોય 3 ને 4 મીટર કરવું હોય તો 4. ઓકે, તો એના પરથી આપણને વેલ્યુઝ મળી જાય. તો આપણે થીટા સી મળશે આપણને એના પરથી 1.44 into 10 raised to minus 3 radians is equal to 0.083 degree. Similarly, for deflection at C, substitute x is equal to 2 in equation of deflection. Then yc is equal to 4.88 mm in a downward direction. Okay. Another example, but we are continuing in next lecture.